All right, we'll pick up with question 31 from the January 2019 Regents. So this question is asking us to find the area of the walking path. The walking path is basically the section enclosed inside of this. So we need to find the total area of this part. So we can break this into several parts, find the individual areas, and then add them all together to find the total area to the nearest square foot. The first thing to pay attention to is each grid square represents 10 feet. So that means that this here is 30 feet up to here, which is 120 feet. And these are already marked off in increments. Why is that relevant? Because it's going to change what my area is. So what I'm going to do is I'm going to find the area of this little rectangle here. I'm going to find the area of this rectangle here. I'm going to notice they're congruent, but I'll do it anyway. And then I'll find the areas of these partial semicircles on the right side and the left side. And I'll add them all together to find the total area. So I know that the area of a rectangle is length times width. Length times width. The length of this rectangle is 10, 20, 30, 40, 50, 60, 70, 80, 90 feet. The width is 1 square, so it's 10 feet. So the area of that rectangle is 90 times 10, or 900 square feet. And the area of that second rectangle, the one up here, it's congruent. It has the same length and width, so it's also 900. And that's the easy part, is finding those areas. This partial semicircle here is a little bit more difficult because I'm not just finding, I'm not just finding this complete and total area, which is half a circle, which is a lot easier. I'm finding this arch. So I've got to be a little bit more clever. So the thing that I'm going to notice is that if this part weren't taken out, say I were finding all of this area, I would have a semicircle. I would have just half a circle. And actually, I'm going to even simplify this. This part over here is also half a circle. That's also half a circle right there. That is some awesome coloring. So together they complete and make a full circle. So I'm actually going to do 3 and 4 together. I'm just going to assume that they're together, that there's this middle space cut out. And then I'm finding the area of a full circle. Like I'm finding like a full circle right there, right? Because that makes my job a little bit easier. I don't have to divide by 2 and then add at the end. So the full circle I would find by doing pi r squared. Pi r squared. The radius of this circle is the distance from the center to the edge of the circle. So the radius is 10, 20, 30. So pi times 30 squared, or 30 squared is 900, 900 pi, is all of that red part together. But I don't want the entire red part because there's a part of this that's like cut out. That's not included in the area. All of this stuff here in the middle is not included. So how do I account for that? Well, if I notice that shape that I'm cutting out on both sides is also a semicircle. So if I put it together, that shape and that side is also a full circle. So it's like I'm taking a circle and I'm cutting a circle out of the center of it. And that circle that I'm cutting out has a radius of 10, 20, 20 feet. So since I'm cutting that out, it's like I'm taking area away. So I'm going to take that 900 pi and I'm going to subtract the area of the circle I cut out, which has a radius of 20, so I'm subtracting out pi times 20 squared square feet, which is 400 pi square feet. So the area I'm left with is 900 minus 400 pi, which is 500 pi. And that's the area of this part together with this part. So those together have an area combined of 500 pi. This has an area of 900. This has an area of 900. So my total area is 900 plus 900. I'm going to use so my total area is 900 plus 900 plus pi times 500. Wait, let's do this. Pi, I hate this little calculator. I don't know about y'all, but it is not useful. Plus 900 plus 900. There we go. So it's 3,370.796, and it says round to the nearest foot. So it's 3,371 feet total. Number 32 tells me to prove that a triangle with these vertices is an isosceles right triangle. That means I need to show some work. This is a coordinate proof, so it's not a two-columner. Because whenever I can avoid a two-column proof, I try to. So I need to prove that it's an isosceles triangle, and I need to prove that it's a right triangle. I'm going to go with isosceles first. Isosceles triangles have two congruent sides. So what I need to do is show that triangle ABC has two congruent sides. That's going to get me to use the distance formula. When you're trying to show sides are congruent, you want to use the distance formula. Looking at this triangle, I probably want to pick the two sides that look congruent to save myself some work. I'm going to assume that AC and BC are congruent. So I'm going to find the distance between points A and C and between points B and C. So AC, distance formula, x2 minus x1, so 1 minus negative 2, or 1 plus 2, plus y2 minus y1, negative 1 minus 4 squared. It's equal to 3 squared plus negative 5 squared, which is 9 plus 25, or 34. So AC has a distance of square root of 34, radical 34. And BC, so now I need to find the distance between B and C, x2 minus x1 squared plus y2 minus y1 squared. That's negative 5 squared, or 25, plus negative 3 squared, so that's plus 9. 25 and 9 is 34. So BC is also radical 34. So I've proven mathematically that this triangle is isosceles. I've taken care of that. Now I also need to show it's a right triangle. There's two ways you can show that a triangle is a right triangle in the coordinate plane. You can either use slopes and show that two sides have slopes that are negative reciprocals, which means that they're perpendicular, which means that they form a right angle. So it would be a right triangle. Or you can use the distance formula on all three sides and then show that the Pythagorean theorem works. So show that if you plug each side length into a squared plus b squared equals c squared, that the Pythagorean theorem works, because the Pythagorean theorem only works in right triangles. So if the Pythagorean theorem works, then this has to be a right triangle. I'm going to go with the slope method. It's my preferred method for right triangles. So now I'm going to find slopes. And again, like I did before, I'm going to pick two sides that look like they form a right angle. There's no sense in finding a side, the slope of a side, if it doesn't look like it's going to give me my right angle. So again, I'm going to find the slopes of AC and BC, because those look like, it looks like angle C is my right angle. I'm not positive, but it's a pretty good hunch. That's going to be my assumption. So I need to find the slope of AC and the slope of BC. And I could memorize the slope formula, but I like, hello W, I like just doing rise over run. It saves me the headache of making sure that I'm keeping track of my positive and negative numbers. Just a lot less work that way. So I'm going to do my slope of AC. I'm going to rise 1, 2, 3, 4, 5, run negative 1, 2, 3. So the slope of AC is negative 5 over 3. And BC, I rise 1, 2, 3, run 1, 2, 3, 4, 5. So it has a slope of 3 over 5. So I can see that these are negative reciprocals. Yay. That means that they're perpendicular. And since they're perpendicular, hello G. Since they're perpendicular, that means they make a right angle, and ABC is a right triangle. And I have all this beautiful work, but I'm not going to get full credit unless I write a beautiful sentence that summarizes my beautiful work. So this is the only part that, now I have to be able to explain why my work does what it does. So I'm going to say that since I lost my handwriting tool, so my handwriting is not going to be as beautiful as it has been in the past, and I apologize. But I'm going to say since AC is congruent, and this is a segment to BC, triangle ABC is isosceles. I don't know either. Great, I took care of that part. That's an easy sentence to write. The right triangle, I like to err on the side of caution and explain kind of every step in detail. Maybe it's overkill, but I'm going to guarantee that I get full points that way. Also, the slopes of AC and BC are negative reciprocals. I know this is painful that I'm writing so slow. If you're okay, I'm just going to type the rest. Thought I'd be cool and write it, but it's going to take too long. And, I've got places to be. Are negative reciprocals. There we go. So they are perpendicular. Thus, angle C, let's move this somewhere where it's legible until I expand my Smart Notebook subscription, is a right angle, making triangle ABC a right triangle. And that'll get me full credit. There we go. So I've explained why it's isosceles. Check, I've explained why it's a right triangle. I have my work to back it up. Therefore, I've proven that this is an isosceles right triangle. Yay. Number 33. Oh, Teresa and Nancy's pools. One of my issues with the Regents lately has been this question. I don't like part of the way that it's worded, but that's okay. We'll deal with it. Teresa has a rectangular pool. I think that's a little bit vague. And Nancy has a circular pool. Again, not entirely true. Nancy has a cylindrical pool. Teresa has a pool that's shaped like a rectangular prism. Information they're for some reason keeping from you, but it is what it is. So we've got Teresa's pool. We've got Nancy's pool. We don't have little nice diagrams. Let's go ahead and draw them. So Teresa's pool is a rectangular prism. Nancy's pool is a cylinder. Teresa's pool is 30 feet long, 15 feet wide, and 4 feet deep. Nancy's pool has a diameter of 24 feet and a depth of 4. They're both filling their pool 6 inches from the top. So Teresa's not really filling her her pool 4 feet. 6 inches is half a foot. So she's not filling her pool 4 feet, she's filling her pool 4 minus a half, which is 3.5. And Nancy's doing the same. Anytime I'm dealing with prisms, cylinders, any sort of three-dimensional objects, even if I'm not sure what I'm doing next, chances are I need to find the volume. So I'm going to go ahead and find the volume of both of these. Just a way to get some easy points on these questions on the Regents is at least find volumes, right? Like, I'm looking at the rest of this thing, determine and state who paid more to fill their pool. They give me all these numbers. I'm a student. I don't know what I'm doing with all these numbers. But I know that I'm dealing with a cylinder and a prism if I was able to decode this. And I have a formula sheet that can help me find volumes of prisms, volumes of cylinders. So I'm going to do that because it's something to get me some of those points. So the volume of a rectangular prism, or any prism, is the area of the base times the height. The base of a rectangular prism is a rectangle. Area of a rectangle is length times width. So the volume of a rectangular prism is length times width times height. So that's 30 times 15 times 3.5. So 30 times 15 times 3.5. That's 1,575 cubic feet. The volume of a cylinder is pi times the radius squared times the height. Pi. The radius, another tip I always give to my students is whenever you see the word diameter, cross it out and above it write r is equal to half of the diameter, so 12. There's no formula where you need the diameter to find. You can find the circumference with the diameter, but you can also find it with the radius. But most of the formulas, you need the radius, so it's just a good tip is whenever you see diameter, cross it out, write the radius, which is half of that number. So pi times 12 squared times my height is 3.5. So pi times 12 times 12 times 3.5 is 1583.36. Another tip I give to my students is round as little as possible until the end of the question. So 2, 6, 9, 7, 4, 0, 9. I know it seems like overkill, but you don't want some rounding issue in here to mess your answer up later. And this is also in terms of feet cubed. And if I've done this, chances are if this were a 4-point question, I've gotten 1 or 2 points already. And that's a good place to be because, yeah, this question seems like a little tricky. But by just finding some simple volumes, I've gotten at least a point out of the way. Like I said, that's a place that I'm comfortable. I want to maximize the number of points I'm getting. And so there we go. All right, but fortunately, we can go further. We can get the full points on this problem. But I just kind of taken this question one step at a time. So it asks us who pays more to fill their pool. So we know that we're looking for an answer in dollars. When we look back at the problem, we get some amounts of unit prices. Not necessarily unit price, but prices. So we're told that Teresa pays $3.95 per every 100 gallons, and Nancy pays $200 per every 6,000 gallons. Issue right now is we have the volumes of these pools in terms of cubic feet, so we need to convert them to gallons before we can start talking about cost. And we got lucky in this problem that they told us how many gallons are in a cubic foot. So there's 1 cubic feet of water is equal to 7.48 gallons. So for Teresa, that means her 1,575 cubic feet we can convert to gallons by saying that there's 7.48 gallons in a single cubic feet. We want to multiply because if we do it this way, we'll get the cubic feet to cancel out and we'll be left with gallons. So if we go ahead and multiply these numbers, 1575 times 7.48, it tells us that Teresa has 11,781 gallons in her pool. 11,781 gallons. And Nancy, who had her 1,583.362697 and so on, and there's 7.48 gallons per every cubic foot. So cubic feet would cancel, and we would get 1583.36269 times 7.48. 11,843.553. 843. Gallons in her pool. And now we can figure out the total cost. So Teresa pays $3.95 every 100 gallons. So back to Teresa. She has 11,781 gallons. She pays $3.95 for every 100 gallons. So multiply by 395 and divide by 100. We'll figure out Teresa pays $465.35. 35? Yeah. Nancy, for 11,843.553 gallons. She pays $200 for every 6,000 gallons. So she pays $200 for every 6,000 gallons. So her 11,843.553 times 200 divided by 6,000 is 394.79. So Teresa pays more. She pays about $70 more. Number 34. Okay. All right, number 34. First thing we want to do is determine and state the length of the ramp. So we're trying to figure out this length right here. We've got a nice little right triangle. Notice that this distance is 6 inches plus 6 inches plus 6 inches, which is 18 inches, which is 1.5 feet. We know the angle of elevation is 4.76. And we're trying to find the length of the ramp in feet. So we're going to set up, this is a right triangle. This is my opposite side. This is my hypotenuse. So we're going to set up the sine of 4.76 is equal to 1.5 over x, where x is equal to 1.5 over the sine of 4.76. 1.5 divided by the sine of 4.76 is equal to about 18.1 feet. And now I want to figure out the horizontal distance. So I want to figure out that distance. I can't set up an equation straight away for that. But I can find this entire distance because this is my adjacent. So if I call this y, I can set up an equation where I say the tan of 4.76 is equal to opposite, so 1.5 over adjacent, or that distance is equal to 1.5 divided by tan of 4.76. So 1.5 divided by the tangent of 4.76 is equal to about 18 feet. But I don't want that entire distance. I just want the distance from here to there. And I found the distance from here all the way there. So I need to subtract out what I know. And what do I know? I know that this distance is 8 inches and this distance is another 8 inches. AKA, I'm going to subtract 16 inches. And 16 inches is 1/3 feet. And then last but not least, this proof, this beast of a proof. I always kind of approach proofs from both ends at the same time. So I start by looking at what I'm trying to prove and figure out, okay, in order to prove that, what do I need to show first? And maybe in order to prove that, what do I need to show before that? So I'm trying to prove that EF is congruent to GH. And I know that in order to prove that two sides or two angles are congruent, usually my best method is to, so again, my method is going to be to prove two triangles are congruent. And I want to pick triangles that these are sides of. And once I prove those two triangles are congruent, because congruent triangles have all of their parts congruent, meaning all of their angles are congruent, all of their sides are congruent, I'll be able to say that EF and GH are congruent by CP/CTC, aka corresponding parts of congruent triangles are congruent. So I need to figure out what are the two triangles that I'm trying to prove are congruent. So what triangles are GH and EF part of? Well, looking at it, I really only see one. GH is a part of triangle GHC, and EF is a part of triangle EFA. So if I can prove these two triangles are congruent, then that would make those segments congruent. So kind of like where I'm going. I know where I'm going. All right, so I know those are the triangles I'm trying to prove are congruent. In order to prove that two triangles are congruent, I need to use side, 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 angle, 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 side, or HL. So I'm going to start looking at what I'm given and mark everything I'm given and see if I can come up with a plan. So I know that, I'm going to highlight, by the way, what I'm trying to prove congruent so I can see it a little better. There we go. Let's do one in pink and one in blue. All right, what do I know? I know that AE is congruent to CG. Beautiful, I've already got a side. I know that BE is congruent to DG. How will that come into play? I know that AH is congruent to CF. Okay, I might be able to come up with something there. And I know that AD, wow, is congruent to CB. Okay, so I've got a lot happening here. So things that I'm noticing immediately, I've already got a side. I could probably do something with AF and HF to come up with another side. So I'll either need to come up with EF and HG being congruent, or I'll need to come up with these angles being congruent. Let's unmark some of these. So my strategy is, okay, I got this already. I've got that already. Because AH and FC are congruent, I can also say that AF and HC are congruent. So I've got a side, and then I'm going to try to show that these two angles are congruent. I think I have enough here to do that. All right, so I have kind of a plan. Now I want to see where I can get, what kind of progress I can make towards that plan. Okay, so what do I know? Relist my givens. The next thing I'm going to do, because I'm going to kind of keep track of what I've done so far. So AE and CG, that's great. That's one of the sides I'm going to use in my two triangles. These other ones aren't entirely sides, but I can also say that HF is congruent to HF by the reflexive property. And since I know that AH is congruent to CF, and HF is congruent to HF, then AH plus HF is congruent to CF plus HF. That's the addition property of equality. Stretching it a little bit because I'm really talking about congruency, but I think that my steps are justified. And AH plus HF is the same thing as segment AF. CF plus HF is the same thing as segment CH. So that means that AF is congruent to segment CH, and that comes from segment addition. All right. This is my second pair of sides I was looking for. Another side. And I said I'm going to try to get that angle A and that angle, what is that, a C? I'm going to try to get those two angles there. I notice those are alternate interior angles. In order to say that alternate interior angles are congruent, I need to say that these lines that they're on are parallel. The first thing that comes to mind is that this is a quadrilateral. If only I knew this was a parallelogram, I'd be able to say that these lines are parallel, but they don't tell me it's a parallelogram, so I'm going to have to prove it. So what do they give me? I've already used this fact that was important. I've used this fact. I've got these two other things that are probably pretty important that I could probably use to show that this is a parallelogram. One thing I know is that AE and CG are congruent, but I also know that these are congruent. So like before, I can use segment addition to say that AB and DC are congruent. And then they tell me that AD and BC are congruent. So why is that important? Well, there's a theorem that says if both pairs of opposite sides of a quadrilateral are congruent, it's a parallelogram. And I've got enough here to make that argument. And I want to make that argument because if I know it's a parallelogram, I've got these opposite sides parallel. If those opposite sides are parallel, these alternate interior angles are congruent. If those are congruent, these triangles are congruent. And if the triangles are congruent, then their corresponding parts are congruent. So now I think I have a full plan in place. I just got to go ahead and write it out. So from my givens, I know that AE plus AH is congruent to CF. Sorry, AE plus BE is congruent to CG plus DG. CG plus DG. Again, because of the addition property of equality. And just like before, since when I actually combine those, I get AB. And when I actually combine these, I get CD. This is just segment addition. Other parts of the internet, you might see it called the whole is the sum of its parts. From step 6, and from this part of step 1, I know that ABCD is a parallelogram. Because if both pairs of opposite sides of a quadrilateral are congruent, it is a parallelogram. Since it's a parallelogram, that means AB is parallel to CD. Oh, yeah, it's CD, right? Yeah. Yep. Okay. Because of the definition of a parallelogram, opposite sides of a parallelogram are parallel. Since those are parallel, that makes angle BAC congruent to angle DCA. That's because if a transversal cuts, parallel lines, then alternate interior angles are congruent. And so finally, triangle triangle BEAF is congruent to triangle GCH. Because of side angle side. And so what was I trying to prove? EF is congruent to GH. Because corresponding sides or corresponding parts of congruent triangles are congruent. And I've proven what I've tried to prove. And that is it. Good luck on your geometry, Regents. You can do it. Just do your best. Try to answer every question. Maximize the number of points you get on the free responses. Don't always try to go for the answer if you can't. Just try to maximize, get a couple points out of it by doing a couple parts. You can do it. Let me know if you have any questions.